Hello everyone, welcome to the video. This is the introductory part of the chapter real numbers. Today we are going to learn about the real numbers. So basically before learning that we have to know about some basic stuff that is that is whole numbers, integers and so on. So we know that whole numbers are the numbers which start from 0, 1 and go up to infinity. They all are positive integers. So when we count the negative parts of the number, for example -1, -2, -3 up to negative infinity, we call them negative integers. So what is integers? Integers are the collection of whole numbers plus negative integers. So in whole numbers, if we start counting from 1 to infinity, they are called natural numbers. So we can say that integers is what? It is a collection of negative integers. These are negative, these are natural numbers, and they are already included in the whole numbers. So integers are nothing but collection of negative numbers and positive numbers. That also includes 0. So this chapter is all about real numbers. So we learned the basic stuff. Now we are going to learn about the real numbers. So what are real numbers? Real number is a collection of rational numbers and irrational numbers. Before going ahead, we are going to learn the difference between rational number and irrational number. So for example, we have two numbers here. We have two numbers, or let's say we have a set of different numbers: 0, 1, -7, 4 upon 2, 7 upon 3, in such a way. So can we say that 0 is a rational number or irrational? So let's start. First, here is a 0. So by definition, rational number is a number which can be expressed in the form of P upon Q, where Q cannot be 0. What does this mean? It means that we have a numerator and a denominator. In any case, the denominator cannot be 0. In any case, if it is 0, let's say 2 upon 0, this is not a rational number. So this is the first condition. Now checking for 0, we can say that if 0 upon 1, can we say that it is written in the form of P upon Q? Yes, we can say that. 0 divided by anything is nothing but 0. So and our condition is that the denominator should not be 0. It is not 0, it is 1. So we can say that it is a rational number. If it is written as 0 upon 3, we can again say that it is a rational number. No problem in that. Now coming to 1, we can say that yes, 1 upon 1 or 1 upon 2, it is rational number. Coming to -7 or -7, -7 upon 1, -7 upon 2, -7 upon 3, if it can be written in the form of anything where denominator is not 0, it is rational number. Here it is written 4 upon 2. We can also reduce it to 2 1s are 2, 2 2s are 4. It is written as 2 upon 1. It is rational number. Now we are going to learn the basic difference between the rational number and irrational number. See, rational numbers can be expressed in the form of terminating and non-terminating decimals. It can be written in terminating or non-terminating decimals. For example, if we write 7 upon 16, it is going to we are going to get 0.4375. I have just taken this number. So we know that now this number has been terminated, so it is a terminating, so it is a rational number. Now coming to the another example, we have 10 upon 7. When we are going to divide it, we are going to get 1.428571, and it is going to repeat itself again and again and again and again. So we can say that if any fraction has a terminating decimal, it is a rational number. If it has non-terminating but repeating numbers, okay, this is very important, repeating numbers. If a number has non-terminating, it is going uh, again and it is going to come again and again, but the numbers are repeating itself. Okay, we are getting this number here again and again, so repeat. If number is being if numbers are repeating after the decimal, it is a rational number. But if we are getting a number which is not repeating after the decimal, then it is irrational number. Let's say for example, if we are getting any number, there is a number in the form of, in a fraction form, and after dividing it we are getting like 0.345370119 and so on. No number is going to repeat itself, then it is irrational number. This is the major difference. Now in the exam we are going to get questions of the very basic type. For example, there are going to be question where we have a fraction for, let's say, 1 upon 5, and they are going to ask us to change it into decimal form, in decimal form. Or we are going to get a decimal number for, let's say, 3.28, and they are going to ask us they will be asking us to change it into P upon Q, change into form of P upon Q. So we are going to do that right here. How are we going to change this number into decimal? 1 upon 5, we are just going to divide it by 5. So here 1 is smaller than 5, we are going to put a decimal here. Now it will become 10, so 5 2s are 10. We got a number 0.2. We have changed the fraction 1 upon 5 into terminating. Also write that it is a terminating decimal. We got our answer just after the first division, so it is a terminating decimal. It is a fraction number, a rational number. Next we are going to change that this decimal number into the form of P upon Q. How we are going to do that? We are just going to remove this decimal. First we are going to write the numbers here, 3 2 8. Now we are going to, this decimal changes into 1, and the numbers after the decimals are going to change into 100. So this is very easy. Now we can just reduce it by dividing itself. Let's say for from 2, 2 5s are 10, 0, 2 1s are 2, 2 6 are 12, 2 4s are 8. We can again divide it. 2 2s are 4, 2 5s are 10, 2 1s are 2, 2 3s are 6, 2 2s are 4. Now I think I made, oh, here it should be 1. So 2 8s are 16 and 2 2s are 4. We got 82 upon 25. We have changed it into the form of P upon Q. So these are the basic questions. Let's say we have a question that change 1.62 bar in P upon Q. So what does this bar mean? It means that the number 62 is going to repeat itself infinite times. Here Q cannot be 0, we know that. So we can say that, or we can write it like this: 62 62 62 ... So now we are going to write it like x is equal to 1.626262. Then we will write multiplying both sides by 100. Why 100? Because we will get a number, then it will shift these two numbers before the decimal, and so 100 multiplication this side and 100 multiplication this side. This will change into 100x and this will change into 162.626262 like this. This was our first equation, and this is our second equation. So we are going to subtract second equation, this one, from first equation. Now you may ask why we are subtracting 2 from first and not first from second. It is because we always subtract larger from the larger number. Here larger number is 100x and smaller is x, so we are subtracting from 100x. Okay, I hope that clears your doubt. So when we subtract x from 100x, what we will get? We will get 99x. And here if we subtract 162.6262, subtract 1.6262 like this, so this part is going to be 0. What we will get here? We will get here 161 is equal to 161. So now we are just going to write x is equal to 161 divided by 99. This is our fractional value or rational value in the form of P upon Q. I hope you get it.